Imagine you live in a world where you wake up in the morning and you have to go to PyData. It's a hypothetical scenario. And because it's change of schedule, your personal assistant comes to you and tells you, based on the real-time train schedule, there's going to be a delay, so you better leave at 8:13 a.m. Now, that personal assistant is pretty cool, and it's nice to have one. So our next speaker, Javier, is going to tell you exactly how you can build your own personalized commute assistant. He's an LLM research engineer at Hopsworks and is also pursuing his PhD at KTH Sweden. So please give a warm round of applause for Javier.
Thank you, everyone, for coming, and thank you, Priya, for the introduction. So what I'm going to talk about today is how to build a personalized commute virtual assistant with Python, Hopsworks, and using LLM function calling. So first, let me spend a couple of minutes introducing or explaining what is function calling for those that doesn't know. So we all know that LLMs are trained on large corpus of data. So basically, they have this understanding of the human language, and they have a broad knowledge of the world. But it brings some limitations. Like there are some limitations with LLMs. The knowledge is fixed, and also, therefore, is outdated because it will not evolve over time. So this is called the cutoff date. It's basically the date previously, up to which they have knowledge about the world. So, for example, if you take GPT-4o or the mini version that were released in the past months, they have a cutoff date on October 2023. So basically, if you ask the question, who won the Euro Cup, football Euro Cup this year, we all know that it was Spain, and I picked this question not because of my nationality, but it was just a mere fact. But if you go to GPT-4 and ask the same question, you will actually not get the same answer because it doesn't really know what happened this year. So this is a limitation, and how can we fix this? There is a technique called retrieval augmented generation that you might have heard already in other talks, which is basically a technique that allows you to enhance the user prompts with contextual information or personalized information or real-time data, basically to help the LLM to provide more accurate answers. So basically, if imagine this scenario, you as a user send a question to a virtual assistant that is backed by an LLM. First, the virtual assistant will just retrieve information from an external source. For example, for the case that we said before, it can go to the Wikipedia page of the Eurocup and retrieve the information and then pass it to the LLM. So it's more or less like whispering the LLM about the recent happenings or activities. But there is still a problem here, which is what do we download exactly, or what we fetch exactly? We cannot fetch the whole Wikipedia and pass it to all the questions, just in case we are asking for this specific year. So this is a problem still, and how can we fix this? So there is another technique, which is called LLM function calling. Is the ability of LLMs to impute the user intention in the prompts, and then decide whether to execute a function that is available on a set of functions that we define to the LLM. And also, the LLM is able to define the parameters that we need to pass to this function. So taking into account the same example that before, now when the user sends a question to the virtual assistant first asks the LLM what to do next. Is there any function from this set of available functions that I need to call first to retrieve some specific data. For example, I might need to fetch information from Wikipedia, but I only need this year of information or this specific page. Then basically the LLM will answer with a function. The virtual assistant will go to retrieve this external information and put it in the, together with the prompt and pass it to the LLM. So basically, LLM function calling enables a wide set of different approaches to build LLM systems. You can basically assign functions or define functions to fetch data from different external sources, or also to make REST API calls to perform some kind of operations or talk to other LLMs as well. So now that we have defined more or less what is function calling, let's see how can we build LLMs with function calling with Hopsworks. So Hopsworks is an AI lakehouse built around a feature store that helps you build streaming, batch, real-time, and LLM systems following a set of good practices. One of the good practices that we often explain is the FTI pipeline architecture, which is basically a classification of AI pipelines. We have, on one hand, on the left, a feature pipeline, which basically takes raw data as input and then outputs curated features and labels. Then we have, in the middle, the training pipeline, which will take features and labels and train a model or fine-tune an LLM, for example. And the output will be this trained model or the fine-tuned LLM. And then we have the inference pipeline, which will get as input a trained model, also features, and also the user query in this case, and use the model and perform some function calling or call some functions to get external information and so on. And then the output would be the answer, the prediction, or whatever use case we have. So how does Hopsworks integrate into this FTI pipeline architecture? It basically provides different abstractions, such as a feature group, feature view, and so on, to make it easier for you to follow this, this classification of pipelines. So for example, we have feature group that is basically it's a group of features that make sense together, so they are semantically related. We can think of it more or less as a table in a database, but it's more complex under the hood. So the idea is that the feature group abstracts all the complexities under the hood. Also, we have a feature view, which is a query. It's a feature selection, so you can pick features from different feature groups in your feature view, and you will use it to retrieve low latency features or create training data sets or so on. And then, basically there is a model registry that you can store the models, model serving, where to run these LLMs or other models with GPU management as well, and data monitoring, but that's for another day. So now, what about the Commute virtual assistant? So we want to build an assistant that, in this case, will take information from SL, which is Store Stockholm Local Traffic, which is the public transport in Stockholm. And they provide APIs to retrieve real-time information of departures at different stations. And you can see the scheduled times, expected times, if there is some delays, if there are issues, deviations, and these kind of things. So using the diagram before, basically what we will have as raw data is a data stream. We are running a program. I will be running a program in the laptop that basically pulls information from the SL API. This is real-time information about departures. And we will have a streaming feature pipeline that takes this information and will curate the features and also compute aggregations at using different windows. So we will have not only a specific departure, if it was late or not, but we also have like aggregations, how many late departures were in the last 30 minutes, in the last hour, in the last 6 hours, and so on. Then we have a training pipeline. In this case, we fine-tune an LLM to teach the LLM some specific jargon about the departures and the public transportation, but also we train a model to make predictions based on the current schedule, let's say, and the current status of the buses going around the city and the metro, to make a prediction about how possible it is that the bus that I want to take is going to be late or not. Yeah, and then finally, the inference pipeline, which is basically we will have running this late departure predictor model. We'll have it running in a deployment. And then on the other hand, we have the assistant backed with an LLM and also configured with function calling. So possible functions that we can add, for example, to our assistant would be one function to retrieve historical information about the departures. So we can then ask questions, for example, how many late departures were like last month or last year, and things like that. Also, another function could be the second one, which is we can make a prediction based on the current status of the departures. And also, we can keep adding more functions like can you estimate the arrival time at my office, or is there any, no, how many ASUS were registered up to now, and things like that. So, okay, this is, let me go for the demo. Let's see if I can skip this part. You see this one, okay. All right, so this is the Hopsworks UI. So as I mentioned, I already created different feature groups. We have one feature group for users, another one for sites, departures. These are the 3 feature groups with, for the different aggregates, and then departures with all the departures. So we can see, for example, I hope the internet connection is good enough. OK. So we can see the list of features that I selected for this feature group. We have ID, the site, schedule, at what time is expected to arrive, the state, and the last one is the label. Is basically what we want to predict is if it's late or not. OK, then this is also the aggregation feature group, which is basically more or less the same features as the other one, but aggregated at different windows. And then I created also feature view that basically selects features from, we can see it here in this diagram, from the different feature groups and join them together. So out of it, I can generate different training data sets that then will be used to train the time series model that predicts if there is delay or not. So this is just for the predictor that will try to estimate if there is delay or not. All right, then on the other side, I have here a deployment, which is the mention that I model that I mentioned already, which is the one that makes predictions using the current state. And then I have different notebooks for the different pipelines that I showed you in the diagram before. So in this first notebook is just ingestion pipeline for the users and the sites. So we basically just need to use the Python library for Hopsworks to connect with the feature store, and then you read your users, which is static, it's not real time. So you have your set of users. You convert it into pandas, you write it into the feature group, and also for the sites, you do the same. The sites are pulled from, we have it here, from the public API. Maybe it's too small. Yeah, OK. So in this one, we basically create the feature groups for users and sites. Then we have this second notebook, which is the streaming feature pipeline. For that, we are using quick streams, which is a Python streaming engine. And we basically read from a common Kafka topic that we are sending all the departures. This is done by another application. The problem is that I don't want to rely on the internet connection. So I may not run that one. Or let's try, actually. So this one is a Python program that is supposed to connect with Hopsworks and read all the time real-time departures from the API and just send it to a common Kafka topic within Hopsworks. So I will stop it just because of the connection, but yeah. Then in this streaming feature pipeline, we basically read the data from this topic, compute the aggregations using quick streams, as I mentioned before. So they provide the concept of a streaming data frame. You create that one, and then you can specify aggregations with different window sizes. So basically, we compute aggregations, and then we send it back to the feature groups. Then the third one is the training pipeline, which we get the feature group objects. We define our query that we have here. So basically, you can say, from this feature group, select all the features except those ones, and join with this one and with the other one, selecting the features that I really want in my feature view. Then after that, we can just create a feature view specifying which is the label, and also for the feature groups, you can specify the primary keys and event time columns and so on. Then the feature view, after that, enables you to get low latency feature vectors. So for example, this is an example. If you pass the ID of a departure, the feature vector will give you all the information, the current information about that departure, and send it back to you. And then with that information, you can just pass it to the model that will make, in the end, the prediction. Another use case for the feature view is, as I said, creating trained data sets. So we create the trained data set here, but we don't need to have a look at that right now. We just train an XGBoost model for that, register it into Hopsworks, and that's it. The inference pipeline. This is the cool one. So first, I will try to run it. OK, let's run it. So I ran already those. So we are first connecting to Hopsworks, using hopsworks.login, getting the feature view, and then we can initialize the batch scoring functionality of the feature view. Then get model serving will connect with the model serving capability in Hopsworks to get the specific deployment that I mentioned that predicts if the departure is late. So we can get that one as well. And then we will load our LLM. So as I mentioned before, we are using a fine-tuned model based on Mistral. And I can show you a little bit. So it's this one, OpenHerms. And we basically have two templates. One prompt template for the first iteration when we ask the LLM, is there any of these functions that you need to call to get some data? So this is one prompt. And the other prompt will be the final prompt that we basically ask the final question to the LLM just to get an answer that will be provided to the user. So this one here, let's have a look at the other one first. This prompt here is basically saying, giving some instructions like, OK, you are a helpful assistant with access to the following functions. And then we pass information about the functions that are available in the system in a string way, in a JSON format, let's say. So we basically specify the names and the type of arguments. So right now, we are using two functions. We are letting the LLM know that there are two functions available. One of them is predict late departure at the scheduled time, And the other one is get departure history in a date range. So as I said, we explained the LLM that you are a helpful assistant, and these two functions are available in the system. We give some instructions saying you need to choose one of the functions if it's possible. If you don't know what to do, just say that you don't have enough information. And you have to pass the parameters in this specific format. And then we provide some examples as well within the same prompt. We provide some examples like, OK, if the user asks you, how are you, there is no need to run any function. If the user asks about probabilities of a departure scheduled today being late, then you might need or might want to call the second function, and so on. So we can put all of this in the same prompt. And then finally, there are here some specific tag to tell the LLM what's the actual question of the user. So in summary, this is the first prompt that basically takes the user query and also a JSON representation of the functions available in the system, put all of them together in the same prompt, and pass it to the LLM. This is the first iteration. Then the LLM will tell you, we need to execute this function, or this one, or none of them. So that's the first one. And then the second template is the following, which, again, it explains that you are a route planner assistant that helps with analysis of public transportation data. Here you have some instructions. There is a context. In this context is basically the information that we will be fetching from the when we run the get historical information about departures. Or in this context also will be the prediction when we call the second function to get the prediction. And then also we tell the LLM actually which day is today, because for some of them, those functions, for example, if you ask, are delays expected today, then the LLM needs to know what day is today. So we also add that in the prompt, that today is, and then the value. And we pass the question of the user here. I think this is more or less all here. So let's see if this loaded. OK, we run this one. I think it should be already loaded in the GPU. I hope this doesn't take long. And then, yeah, another thing I didn't mention, basically we use LangChain to orchestrate the use of the prompt templates, to basically use the template to generate the prompt, pass it to the LLM, then I get the answer, and then like more or less to orchestrate the flow of asking of questions and answers. And also to keep track of the history of the conversation. So if I ask, for example, about delays last month, and then I ask about last week, it shouldn't need to retrieve more data, because within the last month, there is data for last week. So sometimes the LLM already knows that, and it doesn't request executing the second function. So it is loaded into the GPU. OK, first question. Whoa, is it me? No. OK. So first question. We ask, hi, who are you? And we got, yeah, hello, I'm a route planner assistant, that can help you with analysis, Then the second question, are there expected delay departures today? So here, notice we didn't mention which day is today. It's just we only say today. OK. So we only mention today. So the LLM already has the information that today is 19th. And then also it knows that it has to request to make a prediction of the probabilities of late departures today. So under the hood, it was sending a request. It was asking for the execution of one of the functions that we pass, which is basically sending a request to this deployment that I mentioned before, this one here, and with departure IDs. And then in this deployment, we basically take these IDs, we use the feature view to retrieve all contextual information of these departures that are happening right now, and make a prediction if it's expected to be some late departures or not. So this is happening under the hood, basically. And the result of executing that function is this one. The deployment basically responded with probability is actually very low, and yeah, the scale you ask for today. So it is saying you ask for today, basically, and it's very low. So then the LLM basically builds the answer with all that contextual information, saying there is a probability of late departures today, but is quite low. And it actually parses the value into kind of percentage or something. I mean, it's not correct, but yeah. And then we can also ask, were there expected late departures yesterday, or if we go to the next one, actually, this one may be a bit more tricky. How many late departures are from 10th of September until 19th of September, so until today? In this case, we are asking for late departures within a specific time range. So the LLM understood that it needs data from these days about the departures. So it called one of the functions, the one that was saying get historical information, data. And in the parameters, it specified the start of the time range and the end of the time range. Then this function was executed, and we can see there basically everything above that line is like for debugging purposes. So I'm just printing things that are happening under the hood. So this information is basically what we are getting from executing this second function about the historical information. So we see like dates, severity for the deviations that have happened, number of issues, and so on. And then this is passed again to the second time that is sent to the LLM. And the final response is, between these days, there have been no late departures reported, because effectively there were not there. So I'm not printing all the context. It's just to make it more readable. Yeah, we can. Let's see if this works. Actually, I haven't tried. How many departures? Issues. So now we are not asking for late. So departure issues occurred last month. Last month, there were no reported departure issues on the public transport in Stockholm. So, two things. One, you see that there is no this type of table, right? This type of table kind of, it doesn't appear here anymore. That's because the LLM already has all the information that it needs, because actually, in the database, in the feed store, I don't have 1 month of data. I just have like several days. So if you ask for like from 10 to 19th and you ask for last month, it's the same data, because I actually don't have more. I was running this like a couple of days ago. So it's not asking again to execute the function to retrieve historical information. But it's able to answer anyways. There are no reported departure issues on the public transport. So yeah, I think I'm running out of time. So let's, we can wrap up here. Yeah, so there is a community version also of Hopsworks that is free to use. You can run this kind of projects or tutorials. You have like several feature groups. You can deploy models and so on if you want to try, or just ask some questions in the community, or if you have some questions right now, I will be glad to answer them. So thank you very much for coming and for listening.
Hey. Hey, thanks for the talk. Yeah, I was wondering, because you explained a lot about this like that you query the LLM twice, but how does actually the calling the functions work? Yeah. Is it something you can share?
Yeah, so I didn't go through because of time, but basically, it is here. Yeah. We have this. So we first ask the LLM, right? And the LLM will send us a text saying this function with these parameters. It's actually using the same template that we were using as an example. So it's just the name of the method and then filled with the parameters. So what we do is, in this function here, we just use regex to search for the specific tags. We were using this kind of tags. I don't know if you see it, but it's like one function call, and then the function is inside. So we just get the response, look for these tags. If there is any tag, it's because the LLM is asking for it. So then we extract the actual name of the function with the parameters. We extract it, and then we call this other function, which is invoke function, which will do some magic, trying to first get the name, try to load it if it's available in the sys path in Python, and then execute it with the parameters and so on. So it's kind of manual interpreting of the LLM. The LLM cannot really call anything. It's just, But given the tools, it can precisely tell you what to execute, name and parameters. So you just extract and run it.
Thank you for the talk. Actually, a question, just following up on the same point, just a clarification. So basically, you need to write a prompt example for each function you want to call, so that LLM understand if I have a question similar to the example, I need to call that specific function. Is how it works, or?
Yeah. So it's actually one prompt only with all the functions and also the examples and everything is in the same prompt. And the way we add the description of the functions is you can actually use the doc strings in Python. So I have this method here, which is serialize function to JSON. I pass the function here to this method, and it's basically building a JSON with name of the function, description of the function. And this func doc is basically taking, these are my two functions here, the real functions. I have some doc string, you see, with the description. So this will be part of the JSON that is built by this method to explain the function. And then the output of this method, we put it in the prompt, in the first prompt here. It says, to use one of these functions, respond strictly with then the tags, so we are able to identify them later. And then fn. Fn is basically the, what is fn here? Yeah, it's the format that we want the answer. Yeah.
Okay. And but how the LLM can understand for a similar question to call the same function?
Yeah. So sometimes it fails, of course, because it's like if you have questions that are really close in what they mean, then it might think, okay, I need to execute this one, but it's wrong. Yeah. But
okay. Thank you very much.
Last question.
Hi. I had a question about the context. So you create features and stuff, but I'm not sure how you use it here with the LLM, because if you have a large context, you have a lot of tokens.
Yeah.
So that's normally quite limited how many tokens you can send.
So you mean what is the context of for the questions, or?
Yeah, the features you used for training the model and stuff, do you use it also for the LLM, or is the LLM just this prompt?
So so we send these prompts to the LLM, then the LLM asks for these questions to be executed. These questions, these functions, I didn't show them, you're right. So these are the two functions that we are telling the LLM that they exist. And if you see inside the first one, for example, the predict late departure, we are basically getting, with the feature view, we are retrieving the feature vectors with low latency, which is the contextual information of the current departures, and then we call model.predict to make the prediction. And then in the second one, which is get departures history, again, we basically parse the dates that the LLM is sending us, and we call feature view get batch data. So it will retrieve batch data in these two, within these two dates. And then we return the pandas data frame. And then, yeah, we basically serialize, convert it to kind of table to put in the prompt. Yeah.
Okay, thank you. And very short question, is this code also somewhere on the internet?
Not yet, but it will be here. So, okay, maybe. Yeah, Hopsworks does tutorials. We have different examples here, different tutorials. So it will go here, advanced tutorials. We already have one which is the same, but for Bitcoin. So it's basically, it's not yet. Okay, but we will have that. So there are two, one for the Commute assistant, and the other one is for Bitcoin. It's fetching real-time information about Bitcoin prices and trying to predict, and also ask questions about the past.
Okay, great. Thank you.
As we are at the end of our time now, that was the last question, but Javier will be around for more questions.
There is one last thing. Like after the talks, if you want to pass by, we have beers, and we can chat if you want. So yeah, feel free to come after the talks.
Give it up for Javier.
Yeah. Thank you.